introduction, differential and integral calculus for function of several variables extends the concept of single variable calculus to function that more than one variable. This branch of calculus is essential for analyzing and solving problems in multiple dimensions, which is crucial in fields such as physics, engineering, and economics. There are a few important theory and key concepts that can be used for solving optimization problems in real-life application. Key concept: partial derivative. Partial derivative measure the rate of change of a function with respect to one of its variables while holding all of the other variables as constant. For a function fx, y, the partial derivatives are denoted as fx, y equal to lim h to 0, fx plus h, y minus fx, y divided by h, and also fy x, y equal to lim h to the 0, fx, y plus h minus fs, y divided by h, provide that limit exists. Notation for partial derivative: if z equal to fx, y, we write fx, x, y equal to fx equal to partial derivative f over partial derivative x equal to partial derivative over partial derivative x, fx, y equal to partial derivative z over partial derivative s equal to dxf, fy x, y equal to fy equal to partial derivative f over partial derivative y equal to partial derivative over partial derivative y, fx, y equal to partial derivative z over partial derivative y equal to dyf. From here, we can conclude that to differentiate respect to x, assume that y is a constant and differentiate as usual. To differentiate respect to y, assume that x is a constant and differentiate as usual. Higher order partial derivative is z equal to fx, y, then not only is z a function of x and y, but also fx and fy are each function of x and y. Hence, we may differentiate fx and fy to obtain the second order partial derivative of x. Multiple integral. Multiple integration is actually extend the concept of integration from one variable to a function that more than one variable. Double integrals. Integrate over a two-dimensional 2D region, and triple integral, integrate over a three-dimensional 3D region.
Hi everyone, my name is Lim Wei. My matrix number is 298943. So for our group, we choose the law and the theory of this assignment is chain rule. Chain rule describes how the derivative of a function depends on the derivative of its variable. For example, z equals f bracket x and y. The derivative of z with respect to t is dz over dt equals dz over dx times dx over dt plus dz over dy times dy over dt. So for the chain rule, can only use when inner and outer function is derivative. Next, how chain rules work in various variables. First one is identify the function. For example, is z equals to f bracket xy, x equals to 3t, y equals to ht. Second, compute the partial derivative. First one is dz over dx, the partial derivative of z respect to x. Next, dz over dy, the partial derivative of z respect to y. So, for the third, we start to compute the derivative of the linear function dx over dt, the derivative of x respect to dy over dt, the derivative of y respect to t. Number 4, compare the derivative and sum up chain rule. So next, where chain rules can apply? For the first one is rate of change respect to time t. Optimization problem, we can find maximum point or minimum point of a function with multivariable. Next is gradient of a multivariable function. For the last one is differentiation in implicit and explicit. So next is example of change rules of various variables. If z equals x squared y, where x equals t squared and y equals t cubed, find dz dt. So first, we will find the partial derivative and derivative of linear function. For the z equals x squared y, first is dz over dx equals to 2xy, dz over dy is equals to x squared. Next, for x equals t squared, dx over dt is equals to 2t. So the last one is y equals t cubed, dy over dt is equals to 3t squared. Next, for the last step is multiply the derivative and sum up. So for the solution is dz over dt equals to dz over dx times dx over dt plus dz over dy times dy over dt. So for this solution is equals to 2xy times 2t plus x squared times 3t squared. So for the answer is 4txy plus 3tx squared. So in the further we simplify is equals to tx bracket 4y plus 3tx.
Good days everyone, my name is Teh Khai Yi, and now I'm going to discuss one of the theory with you all, which is Fubini's theorem. Fubini's theorem is a theory that used in the multiple integers. It allows the evaluations of double or three integers as iterative integers. The following two pictures shown are the general formulas of the double integers and the triple integers. But we have to take note that the Fubini's theorem can only apply when a function is continuous on the intervals of rectangle R. So, how the Fubini's theorem works in the multiple integers? The first step, we have to identify the regions of the integrations. For this step, we can sketch the graph of the functions and determine the region. After this, we should set up the iterated integers and determine the orders of the integrations, whether it's dy dx or dx dy. After that, we have to determine the limits of integrations and determine which is upper limits and which one is lower limits. Fourth, after determining the limits of the integrations, we should integrate the inner function first and following by the outer functions. By this 5 steps, a Fubini's theorem is worked and our final answer is calculated. Actually, for this topic, there are many applications used in our daily life. For the differential of calculus of various variables, the first one is optimizations, finding of maximums and minimum of a functions of multivariables. The second, economics, compute the models and optimize the profit, cost, and utility functions. The third is rate of change. And then physics and engineering carriers, computer and graphic fields, and data analysis. This 6th component is U differential of the calculus of multivariables. On the other hand, the integer of calculus of various variables is calculate the surface area, calculate the volume of the solid generated, calculate the mass and the center of mass.
So next is example and the solution for the group assignment. So for the example of differentiation of various variable, this is a question for differentiation of various variable. So after we read the question, you know that we need to determine the function, find the partial derivative, apply chain rule, and the last one is calculate rate of change. So next, we solve the answer with using chain rule. So for the first one is we differentiate with using chain rule in t equals to x squared t plus e power t squared. So the first we differentiate in chain rule 2xt times 2t plus bracket x squared plus 2te power t squared. So for the answer is equals to 4xt squared plus bracket x squared plus 2te power t squared. So when x equals to t squared, then the final answer is we put the t squared into the x, so we get the answer for the differentiation t in is 5t power 4 plus 2te power t squared. So when t equals to 2, the differentiation of t is equals to 80 plus 4e power 4.
Now let us proceed with the examples of the multiple integers. The question states that a solid is bounded under the graph and over the region R, where R is bounded by the graph y equal to x, y equal to 2, and x equal to 0. For the part A, we have to sketch the region of R. Part B, we have to evaluate the volumes of the solids by using double integral methods. First, we have to sketch all the graphs stated in the questions above. The x equal to 0, y equal to x minus y squared, y equal to x, and y equal to 2. So we can see that the region R is correctly bounded by these 4 graphs. For the question B, the solving step is stay beside me. For the first step, we have to determine the orders of the differentiations and write out every information in it. For first step, my outer function is dx and my inner function is dy. My limits for the y functions is x to 2, while for my x is 0 to 2. Because the intervals of the x is fixed, so the limit of y is x to 2. The second step is integrations of the inner functions, and then calculate, and come to the fifth step is the integrations of the outer functions, and continue calculations, and we will finally get a 4 over 3 unit cube as our final answer. Now we have come to a conclusion part. To conclude, multivariable calculus cover the fundamental topics such as partial derivatives, multiple integers, and key terms in vector calculus. These concepts are essentials for understanding and solving the problems in various fields, such as physics, engineering, economy, and so on. The importance of this topic lies in the ability to model and analyze the complex system, the calculations of areas and volumes, and the optimization functions of various dimensions. In my point of view, I think that this topic is quite useful and quite important in our daily life. So that's all in our video. Thank you all.